Hello and welcome to a video, and I'm going to go about how to create a Pi TV version 2.0. But to get there first, we need to talk about how we're going to get there. So years ago, we used to have one of these, which is an Archer multi-video distribution system. It was bought from Radio Shack. This is probably, I want to say 30 or 40 years old now. But what it did is it had various inputs on the back here. So we have our antenna coming in. We have an auxiliary, which was a channel 3 or 4. And we had an auxiliary 2, which had video and 2 audios. And then we could output to 3 separate TVs. So what happened was you would attach this to your cable TV or your antenna. I had it connected to a 15-foot antenna. And then we would mix in this, which was connected to a satellite, one of the big ugly dishes, the buds as they're called. And it got changed to channel 65, I believe. And then this, the auxiliary, we had plugged into a VCR, which got changed to channel 14. And if we look at the bottom of this, you'll see, so the auxiliary 2 could run on channels 14 through 18. And auxiliary 1 was channel 63 to 68. The bad part was it was a potentiometer, so you had to like screw in these to get the actual center frequency for the actual TV channel, which made it extremely hard if you didn't have a TV that had like a tuner that would digitally let you see that. But yeah, this was originally from Radio Shack, as you can see here. I think I bought it like in the 80s or 90s when I was still living at home. But later on, we get some new stuff. And Radio Shack came out with these little boxes, which were a digital version of basically the same thing. It allowed 2 audio inputs, a video input and a TV output. And it was a UHF and cable modulator. And I don't see it on the back here, but it was basically the same thing. It would do UHF channels up there in the 60s, and then the cable, which was the equivalent of the UHF, was in the 90s to 100 or so. I had a bunch of these to make various TV channels throughout the house, but they started dying. So I ended up switching to get some of these, which were Holland Electronics, and they're basically the same thing. They would do cable TV, IRC, HRC, standard def, or standard cable channels, and it also did UHF. You could do the modes, and it was a lot easier because all the channel frequencies were programmed in, so you could just up and down on the channels. But it had the same thing. We had an RF out, the ends, what ohms it was on the video, and then that. These you can't find anymore, and I think some of mine still work, but I switched to a 4-port Channel Master analog one. And if you watch a lot of these videos, you'll see a lot of people are using these now, which are available on Amazon. They're about 30, 40 bucks. But they're basically the same thing. They have the RF in, so you can take your cable, or most of the time it's going to be your antenna, because cable is all digital nowadays mostly. And then you have your video, your 3 composite inputs, and then you can set all the channels and the gains and audio and all that stuff and tell it what channel to do. And then it's got your RF out that you hook back into your TV. So these, like I said, they're about 30, 40 bucks, or at least they were when I bought them. But the thing with all these is they're still analog. And what I wanted to do was HD. So now Amazon has a product on there called SatLink. And what this is the SatLink ST7000, and it's a single channel high def modulator for ATSC and QAM. So I have one of these already set up and running. I bought a second one to set up a second channel. My first channel basically does random TV shows and movies every night. But I want a second one to do other stuff, like maybe it plays movies all day or something like that. But if we go ahead and look here at the device, it's a little bit bigger. But you can see we have RF out, RF in, so you can chain these together, which is what I'm going to plan on doing. I'm going to take the out of one of the others, or the out of this, and it'll be chained to the end of the other one, so they'll all chain down. But it supports HDMI as well as composite. And the nice thing is it has this screw barrel attachment for the power, so it can't come unplugged. But it additionally also has a LAN port, so you can configure stuff through your local network. I don't usually do that. I do it directly on the box because it was just easier and I didn't have to have some device connected to my network to do it. But it's got a really intuitive menu. We'll go over it later. But like I said, I've had one of these running for probably 4 or 5 months now. Seems to be working pretty good. And so what we're going to do is we're going to set up a brand new Pi from installation to finish, and then hook this up and pick a channel and start showing TV or movies. So we'll catch you back in a bit. Okay, so now what we're going to do is install Raspberry Pi OS to our SD card. So on my other ones, I have been using this Buster release, so I'm going to keep using it. I can't remember if there was a reason why I switched to it. I think it had something to do with a certain version of VLC having issues in the newer one, so we're going to go ahead and just use what I have on the other one. So we're choosing Raspberry Pi OS Legacy, and then we're going to choose our 32 gig SD card here, and we're going to do a write. And yep, we understand that it's going to erase everything on our device. So this will take a few seconds or minutes to run, and once it is finished, we will go back to doing the Raspberry Pi installation, and I will bring you back once this is finished. So after you finish writing it with Raspberry Pi, Windows freaks out, and it's like, hey, you need to format this disk before you use it. Make sure you hit cancel. If you format it, you'll just lose everything that you did. So we're going to go ahead and hit cancel, and here it says Raspberry Pi OS Legacy has been written to the generic storage device USB device. You can now remove the SD card from the reader. So we're going to go ahead and do that and place the micro SD card into the Raspberry Pi, and then we're going to boot it up after we attach our keyboard, our mouse, and our network card, and then we'll be right back. Alright, so now that we have the Pi booted, we're presented with a screen like this saying, welcome to Raspberry Pi desktop. Before we start using it, first things we need to do is get set up. First thing I'm going to do is write down my IP address. Because we will use that later to do a lot of the stuff via the command line. And so what we're going to do here, and this is going to be super laggy because of how I'm having to do this. We're going to go ahead and change the let's see here, can we do this? This is what I get for trying to record through a device that's got a 3-second lag. So we're going to change the Raspberry Pi from the United Kingdom to United States. Oh, oh no, no, we don't want Uruguay. Do we have the ability to do... We want to change our time zone next because it looks like it didn't take effect even though we set it in the setup. And we're going to change our time zone to New York City. Tell City? I don't even know where Tell City's at. Excuse me for the lag here. It's how I'm having to capture the display output of the actual Pi. It's going through a device that causes like a 3-second lag, so it's it's a little bit hard to deal with here. So we're going to go ahead and hit next. If we can get the mouse on the button for the next. And probably what we'll do once we get this set up is we're going to SSH into this and do everything through SSH so that I can show the window and what's happening and the SSH at the same time. And this is going to be super hard to deal with. So we're going to type in a new password. Because it also didn't keep the username and password that I had put in during the writing of the setup. So we will use the, I guess the default Pi password. And we're going to click next. Yeah, it fills the entire screen. We'll come back to that later. And let's click next. We're going to skip Wi-Fi because all of my devices are hardwired. And that's because I will be pulling it from a NAS device. So we'll get the best thing for the NAS, or the best speed from the NAS over the wired. We're going to skip doing the updates. I'll do the updates from the command line and show you that. So we're going to skip that, and then we're going to click done. If I can get there. Alright, so now that we've got the Raspberry Pis basically set up for that part, what we're going to do is go ahead and switch and start using some of the command line stuff so I can type and show it faster. So we're going to basically mirror or put the Raspberry Pi up here, but I'm also going to SSH in. Yep. And we're going to log in as Pi and the password reset. If I didn't lag out while I was typing it in. And it looks like I did. Great. Alright. So what we're going to have to do is reset the password on the Pi. And if you don't know how to do that, we'll do this. So the first thing we're going to do is we're going to come up here to this little command terminal icon. And we're having, oh, we did put Pi TV there. Interesting. So if it put Pi TV there, that must mean that this actually should have worked. Yay, look at that. So it actually did work and set the username. It just didn't remember it. And it also set our host name here. So we have channel 62 as our host name. Because we're probably going to end up putting this on channel 62, physical channel 62 RF wise, but it'll probably be virtualized down something lower. So the first thing we're going to do is apt get update, and we're going to get all the patches for the operating system and get it all updated. And then apt-get upgrade. It tells us everything that is going to be upgraded. So it's going to use an additional 3 mega space. So it's going to go ahead and download all the patches and install them. And we will be back once this is done. Alright, we are back, and the patches have finished installing, but there's some settings that we need to change in the config.txt that's in the boot directory. And what these deal with is given the video driver a little bit more memory than what it currently has. So what I'm going to do here is we're going to bring in a config from one of my other ones here. And I believe the only thing that really needs changed is down here at the bottom. We need to add this GPU mem as 256. So let's verify. Yep. So we're going to do insert here and GPU mem equals 256. And we're going to exit out. And what this does is it gives the onboard video card 256 mega RAM instead of the default. I found that this helped a little bit in a couple of the videos that I have, but ooh, I see another thing that we gotta fix here. So this HTML drive 2 is to increase the nope, that is definitely not what we needed. This one. So this is to make audio work out the HDMI port, which is crucial to what we're trying to do here. If we're trying to make a TV station, we want that audio to come out the HDMI side and not out of the analog port. So we're going to go ahead and save that, and we're going to go ahead, then we're going to go ahead and reboot it because we changed the boot config and we also updated the kernel. So we're going to go ahead and do that, and we'll watch it boot here. And it should boot right back up into the desktop where we were previously. Once we're back to that, then we're going to have to install some other software. Now, you don't need all this software. This is for my TV station. But here's a list of the software that we're going to be installing. And I will tell you what each of them does once we get them installed. So we're going to go ahead and restart our session. Log back in with PyTV and our password. And now what we're going to do is the first piece of software we're going to install is the FEH program. And what FEH will do is it's basically like a slideshow program that will allow us to do slideshows of pictures. And I'll show you why this is important later, but what we're going to use this for is to basically black out the whole screen. Because we don't want to see this background, we don't want to see the bars up here, the clocks, the trash, all that stuff. We want it purely blacked out. We're also going to use it in my version to do a bumper between every show or movie where it'll actually pop up and say what the show is, how long it's running, maybe a synopsis of the show, so on and so forth. The other thing we're going to install is media info. This is useful for getting information out of your media, like how long it is, resolution, so on and so forth. I'll show you in a script what I did the first round and why I was using media info. Next, we're going to install screen. Now, there is a way to have, when the Raspberry Pi starts, this to auto run by itself. I prefer to SSH in. I start a screen session, start the script in a screen session, and then I can detach. And then it lets me view a log if something actually happened or broke. So those three things, and then we're also going to install XDO tool. And what XDO tool is going to let us do is get rid of the pesky mouse cursor. So we're going to install that. And the next ones that I'm installing, the PHP stuff, you really don't need. What I'm doing this for is I have all of my media, my movies, my TV shows, they're all in I have them also in Jellyfin. So I use this to extract the data out of Jellyfin, insert it into a Postgres database, and then I have PHP scripts that actually pull the show names, the description and stuff to build all the cards that go in between them, and the GD, and the image that pops up between every show. So I'm going to install these. I'll show you how that actually helps once we get this installed. Like I said, you don't really need the PHP stuff. You can technically do everything with just a bash script if you don't want to have like a bumper between every show saying, hey, what the show is or any of that stuff. But we're going to get this installed, and then I'll be right back, and we'll show you how to start showing shows on your Raspberry Pi. All right, we're back, and now we've got the software installed. Everything's been rebooted. I've copied over some of the scripts that I've done for my other one to this Pi, and we're going to go over what some of the files are that I have and show you what it does. So one of the things I talked about was the FEH program, which basically does it's like a screen saver slideshow type thing. One of the things that we're going to use it for is to black out this screen here. So we can do this with something like this, where we type in FEH. I have an all black 1080.png file. You see it actually runs it, but it still shows everything. So what we need to do is run it in full screen mode. And what we're going to look at is the script that I used to do this. And you see this here. We have -y and a -f and an ampersand. So if we run the all black again with a -y and a -f, now we see the screen is completely black. And the ampersand allows us to put it into the background because we want this to run all the time in the background so that when the VLC is done and it's switching, we don't see any of the desktop from the actual Pi. I'm not going to run it in the background because I want to be able to stop it to show you what it looks like. One of the things that I have on my other channel, or my other Raspberry Pi, is I mentioned earlier, the PHP stuff builds a dynamic image. That dynamic image is updated every time one of the script is run. It's basically called this up next. So if we run this, the up next, what we'll see is whatever it was when I was copying. So right now it says coming up next shows Family Guy episode 1. I am Peter, hear me roar. Runtime was 22 minutes. I was going to end at 2:41 p.m. So that gets displayed for 5 seconds before the show actually starts. So if you're actually watching it, you will see it come up. It'll tell you a little bit about the show and so forth. All of my shows and movies from my library are all on a NAS. So this device has access to all of them. So what I'm going to do is go through some of the thought processes of how I actually built this script out. And what we're going to look at first here is the initial version of the script. And we're going to talk about what's in it. And it's very, very basic. Literally, this will, if you just want something to cycle through a directory of files, this will do it for you. First thing we do is we have to export to display. Because we're running this as a script through SSH and through screen, we have to export to display. This is an X Windows thing, so display equals :0 says take over the screen. And then as you can see here, this is just a while true loop that never ends. So as soon as VLC finishes, it says play and exit. It will immediately go back in and it finds another file. So what this does is it runs the find command. We're looking for any file that's an MP4. The size has to be greater than 100K. And then this here at the end is a shuffle, which is a Unix command to just randomly give me one of the files out of there. That file is then, we then echo it into a log, so we sort of have a log of when it was played, and then it calls VLC and just plays the file. So if we do that here, and I'm going to make this a little bit smaller. Okay, so now what we're going to do is we're going to try to run that file. And I've removed anything that's copyrighted so that it cannot show any of that on the screen. So it's really just going to show a Big Buck Bunny video every time we play this. But it'll give you an idea of what happens. So if we come over here and we run the play.sh.v0, you'll see that it will come up and it starts playing Big Buck Bunny MP4. But it put that title up there. Like, you don't usually see that on TV shows. And if we undo the mute here, you'll hear that it actually is playing the audio. But it's playing. It works pretty well. So this is cool. We have that. And if we hit cancel, it'll go back in and try to play something else. And I also have some SMPTE color bars in there. So it's basically just going to be flipping back and forth between Big Buck Bunny and the color bars. So I'm going to cancel this out a bunch. We're going to get back to the main screen here. We're going to look at how we can make this better, because it's just going to flip back and forth between those two. So what I did next was I found that the Jellyfin library that I use in my Jellyfin server, it produces a SQLite database called library.db that had all the information about all the TV shows and all the movies that's in my collection. And I wanted that information, and I wanted to use it, because that would allow me to do way more cooler things. So what I did this time was I wrote a PHP thing that would basically look at that database and pick a random file out of there. And if we look at that file, what we see is it connects to the database. It runs this select here, which selects out a bunch of information out of there. And basically says where the run ticks is less than 19 whatever number of zeros, because all the data is stored in the database, I believe, in microseconds.
versus seconds or something, or it's something really weird. So you have to do a lot of calculations with it. But what this one does is it'll just pull a random file out of the database and it echoes the path to the screen. So if we go back to the script and we look at play shv1, it echoes it out, it captures it in this file to play, it echoes it into the play log and plays it, cycles, gets another file, so on and so forth. This was cool. It was getting us there, but it was also, I found that the randomization function inside of SQLite wasn't really random. I was seeing like the same stuff was coming up and playing at around the same time frames every day. Which was kind of odd, but it is what it is. So the next iteration of the script that I had is shv3. We started separating it out because I wanted to play TV shows, but also every night at 8 o'clock, I wanted to play a movie. Like one of my movies I wanted to play so I could sit down and watch a movie and then go back to playing TV shows. So this script, we add in some more stuff, some logic to it. So we still have our while true do. We get our hour. And if the hour is less than 20, which is 8 o'clock, or the hour is greater than midnight, then it plays a random TV show. Else, it plays a movie. This worked well. It was an initial thing. It was pretty cool. But we still had some oddity stuff. Like I had the little mouse pointer would still stick up in here and so on and so forth. So what we ended up doing next was, in this one here, I still have the randomness going on, but I also added in the ability to have the bumper between the shows. So here I have this coming up image where basically it was just taking the file and it says, hey, I'm going to play this file. Cool. It was literally just saying I'm playing this file. And we used the timeout command of 5 seconds to have FEH show that file, and then it would start the show or the TV show. Then I decided I wanted way more control. I also didn't want to be playing inside of the Jellyfin library and trying to update it to say whether I'd watched it or not or any of that stuff. So what I did is I wrote a copy program that copied all the data that I wanted out of the Jellyfin database and put it into a Postgres database because I do a lot of Postgres stuff during the day. And now what we have is all the data that I needed in a Postgres database. So I have a random TV show and a random movie one. It still does the same stuff, but I also incorporated updating the upnext.png into these actual scripts here. So when it actually pulls the stuff out, it gets all the information, the name of the show, the title, how long it is, so on and so forth, versus just playing a file. So if we look at this, this file, it gets way, way more involved here. And what this becomes is how I can change what's playing at what time without having to stop the script. I can literally just update this file and the next time it's run, stuff has changed. So what we're doing here is we're setting our default time zone. I'm saying if the hour is greater than 8 a.m. and the hour is less than 5 p.m., we're going to get a random TV show that's less than 30 minutes. Less than or equal to 30 minutes. So during the day, it's just playing random 30-minute or less episodes of some type of TV show. Once we get to 5 o'clock, and we're not 8 o'clock yet, we're going to start playing longer shows. Like I Love Chips or the A-Team or MacGyver or the old Missions Impossible, stuff like that. So it'll play those between 5 and 8. However, I have this clause in here for 7 where it says it has to be less than 19 to play a full 45-minute show, as most of them are an hour-long show. If it's less than that, then it goes for that. However, if the hour is 7 o'clock and it's greater than 30 minutes past 7 o'clock, I don't want to play an hour show because that's going to cut into my movie time that starts at 8 o'clock, roughly. So what I do is I get the difference of the time between the current minute and the minute, the top of the hour, which is 60. And I find TV shows that are underneath of that size so that I can only play those, so I can try to bump up as close as I can get to that 8 o'clock. Most of the time it goes over by 2 or 3 minutes, but it gets up there close to that. The same here. If it's under 30 minutes, it'll try to get something that's less than that. So it could get a 45-minute show. And then if it's outside of this time period, we're just playing anything random. So this is basically my overnight stuff. So you'll notice here I have this play in rotation as true, and then down here is false. So there's certain shows that I do want to see during the day. Those are all marked as true in the database. And that it also has to be that the show hasn't been played as well. With the exception of this one here where it starts getting really little 5-minute shows. But after hours, like, it can play whatever, and if I'm up, I'll watch it. If not, I'm not. So once we do that, we basically get one show because we're using a randomization function inside of Postgres, which seems to not be super, super random, but it works pretty well. We get all of our information back. We calculate some times to say when it's going to start, when it's going to end. Here's our runtime text that says the show runtime is X number of minutes. It ends at X time. Down here is where we make our infographic, where I say, like, hey, here's the coming up next file, which is the basic file that just has the number 9 and coming up next on it. And then I overlay all the text onto it at specific pixel locations. And then I update my TV shows to show that the show has been played, and I add it into a play log, and we're done. And the only thing that actually echoes out to the screen is this one item here, which basically is the path to the show, which when we look back at here, that path to the show is pulled here. It plays the up next because it was created in here, and then it just cycles through and we're done. Which is really cool. And that's basically what the script does now. Is it just sits here and cycles through, plays shows, TV shows all during the day, bumps up close to 8 o'clock. Every night I get a random movie, it'll play that, and then it goes back to playing TV shows. Now, the one thing I did talk about was the little mouse pointer. Because my Pi runs basically headless, I don't have a keyboard or a mouse plugged into it. So every time it boots, the mouse pointer is like right in the center of the screen. To get around that, there is a command called xdotool. And this right here, xdotool mouse move 1920-1080, tells the Pi, hey, move the mouse pointer to 1920 to 1080. And what that does is it basically puts the mouse pointer down here off the screen so that it's never showed up on the, it does not ever show up on the actual screen. This script also has some built-in things into it where I have a stop file where if I touch a file in temp called channel 9 stop, it just stops on the next, after the last movie has finished playing or the last TV show's quit playing, it'll just stop and exit out back to this. It also handles if there's a crash. So when I play a movie, it touches this. So if the script crashes right after that, or the Pi crashes, on the next boot, it won't try to play a movie again if it had already played one for the day. It'll basically go back and say, hey, we're just going to play TV shows for the rest of the night. But that is all on this. So what we're going to do next is hook this up to that modulator and show you how to configure the modulator to get this to output on an actual RF channel.
All right, so now what we're going to do is we're going to set up the SatLink here. I don't have a Pi connected to it yet, but without a signal, it should just give color bars. So I have a little TV here, and it's connected via the RF cable out. And let's go ahead and plug this in and see what happens. So we get this little power light, we get a little display here, and by default, if I can make this a little bit dimmer here, you'll see that it says it's on channel 14 ATSC modulator 473 megahertz, and it has a static IP address of 192.168.1.15. We're not going to use the network stuff, so I'm not really worried about it. But what we're going to do is go ahead and configure this to use a different channel, because I believe I may be using that channel already in my house. So what we're going to do is hit OK. I'm going to go into modulation. We're using American ATSC. We can also use, there's a different way to switch that, but we're doing channel plans. So this is what channel we can use this on. Like I said before, I think I've got 14 in use. So we're just going to pick something above 600 because I have an LTE filter to prevent this from going back out. So we're going to pick channel 39. That seems to be good. So you can see there it says 39, 623 megahertz, and we're going to hit OK on that. Now down here, channel number, this is what is sent to the actual TV for you to change the channel. So even though it's on channel 39, it would say here like you're going to tune to channel 14.1. So we're going to change that, and I'm going to make this channel 10 just for fun. So it'll say channel 10, subchannel 1, so it'll be 10.1 on the TV. And the program name, we're going to change that because right now it says HDTV1. So we're going to change this to say, let's do my, and then we'll do a space here. M O V I E S. So on the TV, it'll show up as saying My Movies is what this channel is. So we're going to set that. We're going to hit return. I'm going to hit return. And we're going to hit return again. And I did the same thing I did last time. I forgot to save it. So what we're going to do here is go back in. We're going to set up all this stuff. And then all the way down here, there should be a setting that says to save. So there we go. So now it says 10.1, 623 megahertz. And now if we come over to this TV and I do a menu, and let's go ahead and do an auto scan. If I can get the thing to actually do it. And we'll do auto scan. Says, are you sure you want auto scan? We're going to hit right for yes. And what it's going to do is it's going to cycle through all the TVs or all the TV channels that it could get for analog and digital. So if we bring this up here, it'll take a little bit, but you'll see here it's on channel 13 physical. So remember, we had ours on, I think, channel 39 or something. So our channel won't show up until it gets up into the 30s. And then we should see a channel 39 or so. And that'll pop up with like one found for digital. You can see it sort of hangs there because it found the channel, so we found one. Now, I'm going to let it finish just because, but there's really no need to let it finish because it's literally only connected to the modulator with only the one channel in it. '50s, '60s. It's basically doing over-the-air scans right now. If I had an antenna hooked up to it, you'd probably see like one or two other channels show up. All right, so we got it, and now because there's nothing plugged in, all we get is the SatLink logo there. And that's the only channel that, and the thing just fell out, the only channel that will show up on this TV is the SatLink one. So now what I'm going to do is I'm going to hook the Raspberry Pi into this, and we'll see if that all works. Okay, so I've got the Raspberry Pi hooked up to the modulator now. So we've got its HDMI input here. Make sure that's in there. Seems like it is. I've got the keyboard and mouse still hooked up. I don't have the network hooked up. Not going to need it for this, but so we've got that all hooked up. So let's go ahead and power on the Raspberry Pi and see how this goes. And we should be starting to see some stuff coming up here, yeah. So it'll flash a few times while it's syncing up. But once it's fully booted, we should have the desktop show up on the little TV there. And there we go. We have the Raspberry Pi desktop on the actual little TV here. And if we go in to our directory, and run our little script here. If I can type right, it's so small on this little TV. And it's not liking something. What am I typing wrong here? Let's take a look. Oh, I got caps lock on. That would be why it doesn't work. And there we go. We've got the it played the SMPTE color bars. So as you can hear, it's a little loud. So we'll turn this down some. But it's actually playing the color bars off of the Pi. And I don't know if this is an endless loop video on that, so I'm going to go ahead and hit Control C, and we'll see if we can try to get the Buck Bunny to show up here. And I may have it locked to where it won't let me get out of that. But as you can see, we now have the Pi with the audio connected up, broadcasting out. Ooh, there we go. Can we quit that? I think we can. And it started playing that one again. All right. So by using this, we can get, ooh, Buck Bunnies may show up here. We can now make what I like to call a Pi Next Gen or Pi TV Station 2.0 that will allow you to not only play standard def stuff, but also HD stuff. So if you have some HD content, whole movies that you want to play on like a TV station, this would work as well. The SatLink ST7000 it's like $250 some, I think, US at the time of me making this video. It is half the cost of the VE coax that I originally bought, and I'm using on a security camera system. The VE coax, though, had extreme audio lag, and I couldn't ever figure out how to get it to fix it. But the SatLink ST7000 seems to be working very well for everything that I needed to do. So I hope you liked the video, and hope you enjoy making your own little TV station with these devices. And here we go. Here's the Big Buck. We'll go ahead and put the audio up. And as you can see, it plays it just fine, 1080p. So again, thank you. Leave a like, thumbs up. Appreciate it. Later.